Thanks for coming to my talk today for about ELT and elections. Like it says, we're also going to learn about, hopefully, some patterns that we can carry across clouds for real-time data analysis. I'm going to go into some detail about a solution that my team developed during the 2024 presidential election. And this pattern that we use to enable analysis during the election incorporates raw data ingestion. It incorporates flexible, scalable transformations that are applicable across any cloud provider. And then, best of all, because we're at the Airflow Summit, it leverages Airflow as the orchestration layer to kind of tie this whole pattern together. If I can channel my inner Big Lebowski, it just ties the whole room together. But first, some introductions. Myself, I am Kyle McCluskey. I'm the Data and AI Solutions Lead at TXI Digital. TXI Digital is a boutique software firm in Chicago. It's been around for about 20 years. And myself, I've spent over a decade launching data engineering teams at startups, and recently I've joined TXI Digital and have been leading the work there that connects large-scale data pipelines with what we're calling real-world operational impact. So what that means is at TXI, we're a strategy-led partner and consulting firm for modern industrials. So think companies that like make, move, or maintain things. So the rail industry, we work with people that make and lease rail cars. We work with freight shippers that use those rail cars to ship product around the country. We work with biopharma companies that research drugs or maybe manufacture drugs. And all of these big legacy firms want to understand how can technology change their business processes and how can data and intelligence really revolutionize their business. So we build intelligent products for them and experiences that help them digitize their workflows and activate data, that's really important, and empower their workforce. My role sits right at the intersection of all of those things, just like data and AI does. And today, I want to share a case study that hones in on the data activation portion of my job, but this time it's not going to be for a big legacy industrial firm. It's going to be in the political ad tech space, and it's going to be about work that I did last year with INTRVL. So INTRVL is a New York-based ad tech firm that runs custom digital surveys and proprietary data science models. So now, what does that mean? I can give you a quick example of the kind of work that INTRVL does so that the rest of my talk kind of makes some sense and you can understand the data products that our Airflow pipelines were producing. So INTRVL runs digital surveys, and this is Steve McAlpine there. He's the CEO of INTRVL. This text that I took was from their webpage, but it sounded a little kind of like advertising-y and Politico-y, so I'm going to kind of explain what they do in more of an engineering type way. But they field digital surveys in digital platforms. So mostly websites starting to get a lot more of their ad platforms on connected TVs because those pretty much work very similar to a website and have a lot of the same technology for how you can do real-time targeting on a television, the same as you could on a website. So, let's say that they've created a very simple 2-question survey. Do you think that school nutrition programs deserve public funding and are important? Yes or no? Do you work in a school? Yes or no? So they might field thousands of these responses, they can track who responded, which way, where the results come back, and then they take those responses, the individuals that posted them, and they start to enrich it with other data sources. So they filter out males from that, and they only focus on women. They take the personal identities of not personal identities in terms of understanding who they are, but demographically being able to bin the people and say, okay, do we think there's a chance that this person speaks Spanish? Even more so, do we think there's a chance that this person might speak the Ecuadorian dialect of Spanish? Okay, and if they do, we're going to look at their history. Did this person vote in the 2nd Congressional District in Pennsylvania? Okay, and then let's bin them up by zip code. Then what we've done is we've created a probabilistic audience of literally if somebody wanted to target Ecuadorian lunch ladies, we have a data-driven way to like bin those up kind of like by zip code. The highest scores are the top third, mid, and bottom. So we have the most likely, good chance, least likely that you're going to get Ecuadorian lunch ladies, and that's the kind of data product that they sell. And so in my talk, I'm going to discuss how we, are first going to talk about the data source that we use to enrich this kind of a product, our early voting data. I have a section here about ELT versus ETL, but I think that for this crowd, that might be a bit too simplistic, so I'll kind of breeze through that, talk about serverless compute, and then finish it up. So I'm going to begin by talking about the early voting data and the data source that we're using. So the early voting data we get from a data provider called Catalyst, and Catalyst is a very well-known data provider in the political tech space, and what their data source gives is voting behavior. It's very important to note that nowhere do we track voting choices, but we have voting behavior indexed to individuals, so things like in this last election, this person requested a mail-in ballot, or they voted absentee, or 4 years ago they voted in person, whatever it is. There's no candidate choice recorded, but there are the voting behaviors for the last 4 or 5 elections that are tracked by individual, and some proprietary issue scores will come out of that voting behavior. So while we can't record or share an individual's voting choice, we can track, oh, this person voted in 3 of the last 4 primary elections for a given political party. So we think there's a good chance that they lean ideologically towards party A or party B, whichever it is. And so they, the data scientists there also send out a probabilistic score from 0 to 1. How likely do we think this particular voter is to support one party or the other based on their voting behavior? It's a subscription model, so we just signed up for one feed, and during election season, we wish that we had Airflow 3.0 so that we could have done data-driven, kind of like event-driven triggering of our DAGs that make this processing. But just to make sure that we were getting data as up-to-date as our customers could process, we probably called our pipeline like 4 or 5 times a day. And it makes sense for our customers. Early voting data should influence targeting, because the models that we come up with target like demographic or issue profiles. So, what that means is, like I said earlier, we have, based on voting behavior, the proclivity to support one party or another. Our data scientists come up with some other profiles, like the language models that I said, maybe your receptiveness to a message that is focused on energy policy or education or whatever it is. In addition to those ideological data attributes, we also have demographic ones that are publicly available: age, race, gender, education, income, things like that. We also have geographic ones, so state is kind of the coarsest grain that we can index somebody on. There's also zip code, and there's also congressional district, and those are all useful axes that we can split our data set on. And then, like I said, the ideological score. So in groups like this, if most members of a group, so like let's say, like I said before, Ecuadorian lunch ladies that live in this particular zip code of the 2nd Congressional District, if we find that 50% of one zip code has voted already and only 5% of another one has, our advertisers, our customers would want to know that so they can move their money into the particular zip code that has more upside, kind of more potential opinions to be swayed by the particular political ad that they're looking to serve up. Okay, so now ELT versus ETL. So I won't go too much into this, but ETL, kind of the traditional early 2000s data warehouse driven approach, like you take data out of an operational store, transform it, and then maybe write fact and dimension tables to a data warehouse. That's one way of doing it. ELT, the process that we're following, is a little different. You connect to an external data source, store the raw data, and then have particular transformations, pipelines, whatever your downstream consumers of that raw data is, process, consume whatever particular partition of that raw data that they're interested in. So we would call using a simple HTTP operator at the beginning of our pipelines, call the Catalyst data source, bring in the most recent early voting data. We put it in a data lake. So we began this process using Google Cloud Platform, so GFS, Google File System, or File Storage, I always forget what the S stands for, was what we used for our data lake. We also had customers that had us do other flavors of this, so it also could be S3, it also could be Azure Blob Storage or ADLS, Azure Data Lake Service. But whatever it is, whatever object store we used for our lake, we put the raw JSON that we got out of the HTTP responses from the HTTP call to Catalyst, and we got it. We indexed it just by time and state. So this is from Mississippi, and this is the epoch time, and that allowed us to make a current and a historical voting profile, from those updates. And so what we have is we have Airflow orchestrating via an HTTP operator the call to Catalyst for the early voting data. We then use an S3 hook to put it into, in this case, an Amazon data lake. Like I said, it also could have been Google File System to put it in. The nice thing about Airflow is that it's got a very robust set of providers and operators that you can use for whatever your cloud provider is that you're getting your object store from. But it puts the responses from the API in the lake, and then some pipelines actually had a call, HTTP call to a service to trigger this specific update. What would have been nice is if we had the event-driven capabilities that are now available in 3.0 to where we could just produce a message to a messaging topic, and anybody downstream that cares about it could have triggered their own transformation. But the important thing is that the raw data was pulled once and stored, and then we had multiple different campaigns, multiple different ad campaigns, not necessarily political campaigns. We mostly worked with super PACs because we wanted a one-to-many relationship in terms of consumers of our data products. But we created discrete serverless functions to really index and kind of cube up all this different early voting data. So the analyses of what percentage of what demographic groups are voting, they could be coarse-grained. Maybe it's just three-dimensioned: age, income, and zip. Who in this zip code that's this old, that makes this much money, has voted or not. But it could be very fine-grained. It could be age, income, education, the language they speak, their ideas on climate, their ideas on healthcare, the state that they're in. Whatever it is, there are multiple different dimensions that our customers asked us for that they wanted to index this data on and calculate these percentages. So nobody saw the schema that we got from the early voting data provider from Catalyst. Nobody saw that schema of which ballot was returned or not. What they saw was percentages by all the different dimensions that they cared about of who they're trying to persuade. So for example, 45 to 55-year-olds with a college degree that made 100 grand in the 60647 zip code of Chicago, 10% of them have voted. And then they could use those percentages to make smart decisions about where they should spend their ad dollars. The results of these functions, of these different ways to create these data cubes, or since it's multidimensional, it's kind of like a data tesseract of all these percentages, of all these different dimensions of kind of voter attributes. They could be stored as Parquet files. They could be stored in SQL tables. That's part of the reason why sometimes customers wanted us to deploy it in their own cloud, so we could just write it to a SQL table for them. We also sometimes had CSV outputs, but that was kind of more for testing because those are a little clunkier to interact with. But the big thing is that we have one pull, so we have one data pull from the provider to store the raw data, then multiple different consumers of that data, multiple different outputs of it. So, you know, one HTTP call might be many Parquet outputs or many SQL tables that are then, hydrated with data. So the nice thing about serverless compute is that, one, it allowed us that flexibility to pull the data once and then have multiple different transformations applied to it. It also forced us into some software development best practices, like, for example, like dry. Like, we wouldn't repeat ourselves. So if we had one way to produce the coarse-grained three-dimension analysis, we just called that once and we didn't have that logic repeated, even if maybe 3 or 4 different super packs might have wanted that orientation of the data. It's also more scalable. So if we got a whole bunch of customers at once saying, I want my analysis now, or maybe we got a big burst of early voting data in, the nice thing for an emerging startup like INTRVL is that we didn't have to hire or provision the infrastructure to deal with those bursts, but we could leverage the serverless compute from the cloud provider to handle that for us. The on-demand pricing for a growing startup was nice too, that we didn't have to pay for a always-on 24/7 service. We only paid for this serverless compute to be executed when it was invoked. And the other nice thing is that it allowed for on-demand execution of these analyses outside of Airflow. So you might meet with the client and they say, oh, I want to run this right now, not necessarily as part of a pipeline, but see it during this meeting, and we could invoke that serverless function ourselves just to produce kind of an on-demand proprietary cut of the data. So multiple customers, multiple clouds, multiple ways to do this, but all the big cloud providers have all of these elements. So, a data lake, it's the same thing as an object store. So in AWS, it could be S3. Azure is Azure Data Lake Service, Google File System. Same thing with serverless compute. You could have Lambdas in Amazon, Azure Functions in Azure, or Cloud Run services in Google Cloud. And the cool thing about this that I would love to have experiment with but didn't really have the time was that if you use some kind of an infrastructure as code technology like Terraform, you could really write the recipe for this pattern in a cloud-agnostic way. And then once you determine the strategy that your consumer wants, you can say, oh, I'm going to provision the AWS version of my data lake or the Azure version of my serverless compute component. And so that was something that I wish that we had had the time to really investigate. So, this is just a visual representation of what this pattern would look like, and don't read anything into the fact that there's only Google and Amazon here. I have nothing against the Microsoft Cloud. I just didn't really like their logos, and they didn't fit, and so I just went with these two. But Azure is also like a very perfectly fine enterprise cloud provider, and this is just what it looks like, and it's the same pattern across clouds. Just some of the flavors of how these different components are specifically implemented in each cloud are a little different. And then, finally, if you'd like to hear more about this pattern, on the Apache Airflow blog on Medium, I just recently posted it last week, a little bit more in-depth, a little bit more in detail of what was going on here, but shout out to Brianna Steele. I don't know if she's here, but she's one of the organizers. She helped me get the long-form version of this up and posted to the Airflow blog. So a bit more in-depth description of it is there. I'm not sure what time I'm supposed to end now, but that's roughly the talk. And if we have any questions, I can take them now.